Hello students, welcome back to my channel NJ Math World. I'm here with your question paper 2023 Discrete Mathematical Structure Part 2 Video 2. So here we are going to discuss about the questions which is in the C session. Each questions carry 8 mark. We have to answer any 3. So here the first question is determine the relation R in the set A. Given A is 1, 2, 3, etc. till 4, 14. Defined as R is a relation where x comma y gives 3x minus y is equals to 0 is equivalent relation or not. So now what is equivalent relation? An equivalent relation on a set is a relation that is reflexive, symmetric and transitive. Now what is mean by reflexive? So we need to prove it is reflexive, transitive and symmetric. Reflexive is nothing but if you have A comma A which belongs to R, for all A belongs to R, it is reflexive. Then if it is symmetric, we need to prove A comma B belongs to R implies B comma A belongs to R, such that for all A comma B belongs to R. It is called symmetric. Then it is transitive. Transitive is if it is A comma B comma belongs to R comma B comma C, we'll continue with B comma C belongs to R implies first and the last number, first and the last element, that will be A comma C belongs to R for all A comma B comma C belongs to R. So now we need to prove this in the given equation. So how we are going to prove here? So now they have given here relation R is x comma y bar 3x minus y equals 0. That means if you consider 3x minus y equals 0, then minus y will be minus 3x, minus and minus get cancelled, you get y equals 3x. So now substituting the values for x, we can get the different values of the given relation. So it will be if x is equals to 1, we will take the values which is given in the set A. X is equals to 1, y will be 3 into 1, it will be 3. If x is equals to 2, then y will be 3 into 2, it is 3 2s are 6. Then x is equals to 3, y will be 3 into 3 is equals to 9. Then x is equals to 4, y is equals to 3 into 4 is equals to 12. So now x is equals to 5, y is equals to 3 into 5, that will be 3 5s are 15. So now how do we write the relation? That is R will be, write it in the form of Cartesian, that will be 1 comma 3 x comma y, it is 1 comma 3, 2 comma 6, 3 comma 9, 4 comma 12. We cannot take 5 comma 15 because 15 is not present in the set A. So this is our relation given in the question. Now based on this relation, we will find whether it is reflexive. We do not have any 1 comma 1 or 2 comma 2 which belongs to R, implies R is not reflexive. R is not reflexive relation. Reflexive relation. 1 comma 1 do not belongs to R, then R is not, if not a reflexive relation. Then second one is A comma B, B comma A. So you can take any one. 1 comma 3. 1 comma 3 implies 1 comma 3 belongs to R, but 3 comma 1 do not belongs to R. We don't have 3 comma 1. Therefore it is therefore it is not symmetric. Then last one, transitive. We'll take the element that is for transitive 1 comma 3 is there, then we should start with 3 only, it should continue with 3, 3 comma 9, then we have 3 1 comma 3 and 3 comma 1 belongs to R, but we need to take first and last, but 1 comma 9 do not belongs to R, we don't have 1 comma 9 in the given function, therefore the given relation is not equivalent. If it is symmetric, transitive and reflexive, then it is transitive. If it is not satisfying this condition, it is not a equivalent relation. Then next one is, they have given the function where the function of f of x is equals to x plus 2 and g of x is equals to x minus 2. Now we need to find the fog and goff. So FOG, fog, will be f of, or this is nothing but bracket of g of x. Let me consider here. So yeah, it is the g of x. Now f of g of x is what? What is the value of g of x? It is x minus 2. Now if you compare this question with this, we can see in place of x I have x minus 2. So substitute in the formula, we get, in this substitute in this formula x value as, that is f of x minus 2 will be x minus 2 plus 2. Minus 2 and plus 2 get cancelled. That will be equal to x. That is nothing but fog of x. Then go for goff. So what will be goff? GOF. Goff of x means g of bracket f of x. So g of f of x is x plus 2. Now comparing this value with the given formula, we have g of x is equals to x plus 2. That means x is taking the place of x plus 2. Now substitute in the formula of g of x. Certainly g of gof of x equals, in place of x we should write this value, that will be x plus 2, then this minus 2 as it is. Plus 2 and minus 2 cancel, gof will be gof of x is equals to x. Then next one, 2n plus 1 divided by. So mathematical induction means we have some steps. Let us call the given term as p of n. So now put n is equals to 1, then it is 1 square plus 2 square. P of 1 equals 1 square plus 2 square. We can write this as P of 1 equal 1 square plus 2 square plus 3 square plus 1 square is n is 1, so 1 plus 1, 2 into 1 plus 1 divided by 6. So here we will be just checking out with the last term, that is 1 square is 1, that will be 1 into 2, then 2 plus 1 is 3 divided by 6. 2 3s are 6 and the 6 get cancelled. 1 is equals to 1, that means LHS is equals to RHS. Therefore, P of 1 is true. Then we will, let us take the second step. Put n is equals to k. Then it becomes P of k is 1 square plus 2 square plus 3 square plus k square equals k into k plus 1 into 2k plus 1 divided by 6. So now therefore P of k is, P of k is true. Now we shall prove we shall prove P of k plus 1 is also true. P of k plus 1 is also true. So yeah, to prove P of k plus 1 is true, we will be considering the number line. Okay. So we have a number line where we have 0, then it is 1, 2, positive values, and this side we get negative values. So same term is been represented in this mathematical induction as 0 can be written as n, then it will be n plus 1, n plus 2, n plus 3, or k plus 1, k plus 2, k plus 3. This will be n minus 1, n minus 2, n minus 3. Now to solve k plus 1, what we need to do is, we'll be taking the formula which is there in the place of k, that will be p of k plus 1. Okay, so we'll be taking this whole term what is given first LHS, that will be 1 square plus 2 square plus k square. Now we should check the term here. You have k means n. What is the next term of n? It is n plus 1. So here if it is k, we should add the next term k plus 1 whole square. So whatever we added to LHS, same thing should be added to RHS. Therefore that will be equal to k into k plus 1 into 2k plus 1 divided by 6 plus k plus 1 whole square. Now taking LCM we get k into k plus 1 into 2k plus 1 plus 6k plus 1 whole square divided by 6. So now if I take k plus 1 as common, what we get? We get k into this 2k plus 1 plus 6 into k plus 1 divided by 6. So now if you simplify this part, k plus 1 by 6, we'll do the simplification and we'll substitute the value. So what's the simplification we have? We have here k into 2k plus 1 plus 6 into k plus 1. So it will be 2 into k into 2 is 2k square plus k into 1 is k plus 6 into k is 6k plus 6 ones are 6. So it will be 2k square plus 7k plus 6. If you want to find the factor method, what we need to do? We need to multiply first and the last digit. 6 2s are 12. We should find the factor for 12. It will be 3 4s are 12. So yeah, we will take this as 2k square plus, in place of 7 we will be writing plus 3 and plus 4, that will take plus 4, then plus 3k plus 6. Then if you take the common elements here, that will equal to 0. That will be 2k common, we get k plus 2 plus 3 common, k plus 2. So that will be 2k plus 3 into k plus 1 is repeated, so we'll write it one time. So this answer we'll write it in this place. That will be k plus 2 into 2k plus 1. Now k plus 1 by 6 into k plus 1 plus 1. 2 can be written as 1 plus 1. Then k plus 2 means 2 into k plus 1. I have here 3. 2 ones are 2. Then remaining is 1. So it will be plus 1. So 2 into k is 2k. 2 into 1 is 2 plus 1 is 3. Therefore, P of k plus 1 is also true for all for all positive integers, for all positive integers n greater than or equal to 1. So the next question is an minus 4an minus 1 plus an minus 2 is 0. We need to find the recurrence relation for the given term. So what we are going to do is, Now let me put an as capital A d power n. So we get a d power n minus 4 a d. Here we have n minus 1, so it will be d power n minus 1 plus a d n minus 2, that will equal to 0. Now divide by a d n minus 2, the bigger power. So if we divide it, we get n minus 2 divided by d a d n minus 2 divided by a d n minus 2. So here what happens? This and this will get cancelled. That is 4 into, no, we have 4 here. 4 into. Certainly this a and a cancel, this a and a get cancelled. So we get dn. If power we take up, it will become negative, minus n minus 2 minus 4 d n minus 1 minus n plus 2 then plus 4 equals 0. So now if we get cancel these terms, we get d square minus 4d plus 4 equals 0. So now find the quadratic form, that is 4 factor 2 2s are 4. So you can write it as d minus 2 into d minus 2 equals 0. So d minus 2 is 0, means d is equals to 2. So the distincts, the roots are real. Now if the roots are real, the general formula will be an equals d power n into c1 plus n c2. So now an we will keep it as it is. D value will substitute 2 to the power of n, c1 plus n c2. Now next step is, we'll take the condition what they have given. In place of n they have given 0, so n equals 0. It will be a naught will be 2 power 0 c1 plus 0 into c2. So it will be what? A naught is what? 1. A naught is 1 equals 2 naught is 1. That will be C. This will become 0. So C1 is equals to 1. Then find for the second one we have n is equals to 1. So A1 equals D is 2 power 1 into C1 is 1 plus n is 1 into C2. So that is A1 value is 3. 3 is equals to 2 power 1 is 2. 1 plus C2. So if you remove this bracket, it will be 2 into 1 is 2 plus 2 into C2 is 2C2. So here 3 minus 2 equals 2C2. So here 1 equals 2C2. So C2 will be 1 by 2. So the value of C2 is 1 by 2. Now substituting the values of C1 and C2 in equation 2, we get an equals D is 2, 2 to the power of n into C1 is 1 plus n, C2 is 1 by 2. So taking LCM here, we get an equals 2 to the power of 2, 2 to the power of n into, if I take LCM, it will be 2, and here it will be cross multiplication, it will be 2 plus n. So now this power of 2 is 1. If it goes up, it will become negative. So an will be 2 to the power of n minus 1 into n plus 2. So this is the final recurrence solution for the given problem. Moving on with the next question, we have, explain which of the following is a complete graph and why. Now what is mean by complete graph? A complete graph with n vertex denoted as Kn is a graph where there is an edge between every pair of distinct vertices. So every vertices should have a edge connected to each other. Then it is called as complete graph. So yeah, how do we identify whether the given graph is complete or it is not complete graph? So let me take one by one. Well, let us solve. So let me take the first one. We have the first graph. Here we can say from the first one, for first one we can say there are how many vertices? Vertices are nothing but points or nodes. So how many points and how many nodes we have? It is 1, 2, 1, 2, 3, 4 nodes, 4 points. V1, V2, V3, V4. Then we will find the edges. Edges are nothing but lines. Edges are lines. So we'll see how many lines we have. That is V1 to V2. We have V1 to V2. Then V2 to V3. V2 to V3. Then V2 to V3, it is again the same. Then V3 to V4, V3 to V4. Then V4 to V1. Then we have V4 to V1. Then we have V1 to V3, V1 to V3. Then missing edge, missing edge. Which is the missing edge here? Here we don't have the edge from A4 to A2 or A2 to A4. So the missing edge is A2 to A4. A2 to A4. This graph is not complete graph because V2 and V4 are not directly connected. We'll check with the second one now. Second diagram, that is for second one, vertices we have V1, V2, V3, V4. 4 vertex. Then edges are V1 to V2, V2 to V4, V2 to V3, V3 to V3 to V4, V4 to V1. Then again here which is missing? The edge V1 to V3 is missing. We don't have this. Here this and here this. We don't have the edge V1, missing edge. We have one missing edge, that is V1 to V3. Therefore this graph is not a complete graph because V1 and V3 are not connected directly. So yeah, what will be the last one? That is third one. How many vertex? It is again vertices are 4. V1, V2, V3, V4. Then edges are V1 to V2, V2 to V3, V3 to V4, V4 to V1, and V1 to V3, then V2 to V4. So here no edge is missing. Here conclusion, it is a complete graph. Since every pair of distinct vertex are connected are connected with with an edge. Okay, if it is connected with an edge, then it is called as complete graph. Then we have next one is Euclid diagram. What is Euclid diagram? Euclid An Euclid graph is a graph in which all the vertices has an even degree. The vertex should have an even degree. Now we will start. Vertex A means how many lines are connected to A. We have to check those lines. So here there is 1 and 2. So there are two edges, that is even. Then for B it is 1 and 2. B is also 2, it is even. Then for C it is 1, 2, 3, 4. It is 4, it is even. Then for D it is 1 and 2, 2 it is even. Then for E it is 1 and 2, 2 it is even. So it says here, what is a Euclid graph? It is a graph in which all the vertices are even degree. Therefore, the given graph is an Euclid graph. Euclid graph. Then moving on to the next question. So here they have given, write the matrix for the following graph. You have to write the matrix for the following graph. So we have matrix. We have to just check how many edges are there between the vertex. V1 to V1. V1 to V1 we have no, 0 it is. V1 to V2 we have 1, which is not going, but we don't have, it is 0. V1 to 3, yeah, it is there, 1 is going, so it is 1. V1 to V4, no, we don't have, it is 0. Then we'll go for the next one. We'll check for the condition of V2. V2, V2 to V1, yes, we have 1. Then V2 to V3, we don't, V2 to V2 we don't have, self loop. Then V2 to V3 also we don't have. Then V2 to V4 we have 1. Then we'll go for the next one. It is V3. We'll go for V3. V3 we have V3 to V4. V3 to V4 we have 1. Then all are coming edges, so we don't have any for others. Then we'll go for V4. Now V4 will be V4. V4 to V3 we have 1. V4 to V3 we have 1. Then V4 to V2. V4 to V2 we have 1. Then V4 to V1. Then 1, 2. Then the remaining is 0. Therefore, the matrix for the given graph is 0, 0, 1, 0, 1, 0, 0, 1, 0, 0, 0, 1, and 0, 1, 1, 0. Then the last here, draw a graph which is both Hamiltonian graph and Hamiltonian circuit. What is Hamiltonian graph? A Hamiltonian path is a graph in a graph is a path that visits each vertex exactly once. See here, it is going only one time. Each vertex is going one time, right? So yeah, Hamiltonian circuit is